let's design some wheels. So as you see, there's the disc. What I did was, I took the wheel I wanted, I wrapped this around, and I literally counted. I know a lot of people are like, you should have calculated the pitch diameter, the teeth, I have no idea what pitch this belt is. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to try 9. I'm going to try 9 and see what happens. Is that incredibly simplistic? Yes. Will it work? Hopefully. So we start with the main disc. We then build this like a birthday cake where we put that on the other side. We then do it again. Do some chamfers. So now we've chamfered the edges of all these surfaces. Probably should have waited till the end on that. Then I went and put the counter bore in here. Once the counter bore's in, we add in the little idler part. Then we add the chamfer. Now we add the teeth. And how I did the teeth more specifically, I drew just this one and I did a view slice graphic. So I drew a square. I measured how wide it was on the old tooth. I then put some beveling on the edges, and then I did a copy rotate 9 times. Finish sketch, which gives me that. Then I went ahead and did some fillets, filleting the front of them to make it more like the tooth off this. Then on the back, it's not a mirror. They're offset from each other. So this one, I couldn't just copy it over. You can see how this is here, then that's there. They're supposed to go in between one another. So I did the same drawing, but I had to rotate it 20 degrees. And I got to 20 degrees. No, I had to rotate it 10. Because you take 360, divide that by 90, and that's 20. But then to split the difference, you only go half that. So half is 10. So it's 20 degrees between each tooth, 10 degrees for this half step. Was that a little bit of math? Yes. Was it necessary? Yes. See, I did do subcalculations. And last but not least, fillets. Lots and lots of fillets. And the drive, this is the idler one, is done. Dun dun dun. Send that off to be print. And slice and print. Alright everybody, here's a look on the inside. So as you can see, the battery is like the majority of this. We have the switch down here, the charging port. There's a little piece of tape that holds the Malanky end so its light is always visible. And that soldering, that cable comes here. I did direct soldering on everything, all except for the battery. And I left the charger port. Charger port's got all the room in the world to just hang out down here. And I was originally just going to make a little Lexan plate, but after I 3D printed that bottom plate for Zip Zap, my little Hypershock clone, I was like, man, so nice just to press print one last time and have something with the holes exactly where you need them. Not play that punch and drill game or making a print to make a cleaner bottom plate. Right now the printer is working on making the axe and the wedges. And then this thing will be ready for some test fights. And what we're going to do is we're going to have it fight 3 robots. It has to get at least 2 victories, or we're going back to the design board to soup it up some more. So, and I really hope it wins because I don't want to do any more design work. Designing is kind of like writing a book. You really need to have the muse and be in the right mood, and it takes forever. You don't feel very good when it's done, but you're always very satisfied with the results. All right, ladies and gentlemen, Here's a very happy spot for every builder. The blue lights are on. I get to turn it on, and we're going to see how it works. It's got some decent forward and backward. That turning's kind of terrible. And the other way. Okay. When you're using a Malenki board, when you get one of these lovely little guys, they come with the dual rate turned down. And believe it or not, this is actually me already turning the dual rate up. To switch that, you have to turn this on, let it blink for 1 minute, and then once it's in that mode, you turn the radio on, and before pushing the stick, you do channel 5 up and down 11 times, and that fixes the dual rate. But even with the dual rate fixed, it still isn't turning like it should. There's a little too much friction, I think, in these wheels. Like, I can't freely turn them. So I think I'm going to go print a new set of wheels, and we will try this again. And I'll try to dig up some of the Tamiya grease, because I got to get the friction down in the treads here. And who said keeping lots of tubs of old things would never use again would be bad? So I used to love these little Tamiya kits. I would steal robot drives out of them all the time. And people who are a fan of Battle Beetle will recognize where that frame comes from. But they provide, these little tiny grease tubes. These are amazing. So step 1, you squirt a little bit of grease on this. Step 2, you take your wheel and stick it on, and that is so much better than it was. Then you stick your washer on the back. Now if you look in the print, I put a little nut inside here. And so with the this special bolt, this shoulder bolt, you screw this in until it's tight. And there we go. Oh yeah, that is so much looser. Grease, it's a thing. Okay, get the old wheels out of the way. Throw out the empty grease. Clear all the parts. And way faster. Lubricating the idlers. I'd wish that wasn't a step, but I will take it. Okay. This might seem crazy, but this is how I'm starting the sketch for my wedge. Now, I have this idea. I want it to look like kind of an iceberg on the front of the robot. And I do want a big wrapping wedge. Something that's got the little deflector plates on the side. So the first thing I do is I draw this little angled piece, which is the main part of the wedge. And then I put the 3 fins that that go into the little fork slots. I take this and I extrude this out into something way longer than I need. Boom. So this is 2.5 inches. I know the very top of the wedge I want about 2.5 inches, but I'm going to cut out my iceberg shape, and then I'm going to chamfer this whole thing on the bottom So next up, I do that, where I chamfer the back and the front. And the way I achieved that was this crazy sketch. And yeah, it's kind of ridiculous. I didn't even put dimensions on this. Man, I didn't realize how lucky I got on that step. From here, now that I've got my fins and I've got more or less the crazy shape I want, I'm going to chamfer something. Chamfering this front edge to make it feel more like a wrap. From here, we're going to add a fillet, and I'm pretty sure this is going to be down here on some of these edges. Yep. You always want to make sure you fillet this. I do this in the beginning. If you have a sharp edge on this corner that drags on the ground and you try to go backwards and it catches a seam, you'll be like, why is my robot not moving? And actually, I want to get a good view for this. Next, we're going to get artsy and fartsy. So, if that looks like I scribbled, I'm going to pull up the sketch and yeah, I totally scribbled. Artsy. Then we're going to bevel a couple things. Next, we did another scribble. And to get this next part to actually wrap the wedge, I did this plane first, and then we do a second one on this surface. So I did one little cut here and then another cut here. But I connected them here in the middle so it looks like it's one continuous thing. Then to make this look more detailed, we're going to chamfer the edges. And boom, all of a sudden that looks a lot cooler. Then we're going to chamfer this top edge. And now this really makes this thing feel 3D and natural. Artsy and fartsy. There it is. I also put a little chamfer here on the top so it doesn't poke me. But that is a pretty cool, like, iceberg wedge. Next, I realized I needed to put the backstop or the wedge would curl under. I had to cut that back open. Then I bevel this. Then I cut away a little bit of the bottom. I did some additional beveling for additional support. And last but not least, put in the hole. And there we have it. 3 little fins and an iceberg wedge. And I did something very similar to make an iceberg pickaxe. Because the robot's Avalanche. 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 So I just made a little pointed pickaxe to go on my standard axe arm. Okay. Let's print all these parts and see how the robot looks all together. Okay. So here's my little ice pickaxe. This robot is going to be Avalanche. And first thing, when setting the servo, drive it to its starting position. This is a 180-degree servo. Yeah. If I was more confident, I would put Loctite on this. Alright. And this all worked in the CAD model. So let's hope it works here. That looks pretty good. So that screw just barely fit in. I wanted this to be easy to change. The real secret to in-game success, easy to change front forks. lock nuts, because I don't like putting loose nuts back on. The servo's complaining. I don't actually need the robot on for this. I'm too lazy to turn them off. Alright. Lo and behold, ladies and gentlemen, this is Avalanche. What is that? Okay, that wedge is too tight. I didn't think I could screw that up, but I found a way. What's the Jeff Goldblum line? Life finds a way. There. I think it's ready for a battle. Alright, ladies and gentlemen, this is tonight's challengers. Its first round will be the Fire Lifter Heatwave. Let's see if this robot can melt some ice. Up next, the robot it was based after, Scoopsy Daisy, our current Tread champ. And last but not least, it's going to be the lifting robot Hiss, coming in to see if it can get a victory. Let's wish Avalanche luck. He's got 3 contestants to fight. Round 1. 3, 2, 1, fight. Okay, Builder Blog. I'm very happy with my little Tread robot. Avalanche here will be a great addition to Bot Bash, and it was a fun little thing to build with treads. But my question for you is, if you had this little Tread base, what would you make? What would your robot and theme be? So let me know, and I will make that clone in next week's video. So tell me, would you make a new Scoopsy Daisy? Would you take this and make orange treads and a robot called Tiger Tank? Like, what kind of tread robot would you build on top of this platform? Let me know.